All right, so now we're going to discuss the composition of functions. We've already talked about adding, subtracting, multiplying, dividing, and now we're going to do another operation which is called composition. So composition is written up here, and I bet you've seen this before. People want to kind of laugh about it and call it fog. Sure, you've done that before. And this is what it looks like. It's f of g of x. And so the way we say it is we say f of g of x. That's how we talk about it. F of g of x. That's how it's spoken. And it is an operation. So they give me a first example. Here's f of x, which is a radical, and here's g of x, which is a rational or a fraction. And they ask me to compute the composition. So the way I write this is I write this as f of g of x, and I use square brackets in there. You really could just use nested parentheses because parentheses and square brackets have the exact same meaning in math, but I'm trying to distinguish it a little bit to make it easier to see. And then without thinking hard, don't even make anything out of this. What in the world is g of x? Oh, it's that fraction 2 of x, so I'm going to put it in there in those square brackets. That's all there is to it. We've not done anything big yet, okay? Just put it in there. Now what we do is we actually plug this into the f function. So now I'm supposed to go to the f function. Here's my f function. And in place of that x, put the mess in the square brackets. So in place of this x, I put the mess that's in the square brackets. So this becomes the square root of 2 over x plus 4. And that's it. And that's it. Now, when you reverse it in part B, this is going to normally be a different answer. This is going to be g of f of x, and I use the square brackets, and square brackets and parentheses have the same meaning in algebra. And then I just say, well, what in the world is f of x? Oh, it's that square root of x plus 4. Okay, and don't overthink any of this. Okay, if you overthink it, then you start getting confused. Now I'm talking about the g function. So now I go to the g function, and wherever there's an x in the g function, I'm going to put that radical stuff in there. So this is going to be go to the g function now, and in place of the orange x, I'm going to put the square root of x plus 4. And there's your answer. Okay, if you overthink this, you will never get the answer. Do not make it hard. It's really not bad. Don't overthink it. Okay, so let's go down to the next one. More composition. Okay, f composition g of x. So this is f of g of x, which is f of, what in the world is g of x? I've got to go find it. Oh, there it is. It's the square root of 5x plus 5. Okay, so now's when I think a little bit. Okay, now I'm supposed to go to the function whose name is f, and in place of the x in that function, here's my f, and in place of this x right here, I'm going to put that square root of 5x plus 5. Okay, so this is going to be 5 times, in place of that x, I'm going to put the square root of 5x plus 5. I got to square it, minus 1. So when I square a square root, what does that do? That's right. It pulls what they call that radicand out, right? It's called a radicand. Isn't that a weird word? Only a math teacher would know that word. And so there it is. And then you distribute your 5, and this becomes a 25x plus 25 minus 1. So your answer is 25x plus 24. Okay, so here we go again on the right side. G of f of x. Don't overthink it. Just write it down. Okay, so this is g of, what in the world is f of x? It is, f of x is that 5x squared minus 1 stuff. Okay, now's when I finally have to ponder this just a little bit. I'm supposed to now go to the function whose name is g over here, and in place of the x in orange, I put the mess in the square brackets. That looks red. Okay, so this is going to be the square root of 5 times all the stuff in the square brackets, which is another 5x squared minus 1. And then there's still a plus 5 on the end. So I replaced the orange x in parentheses with all the stuff that was in the square brackets. And now I just clean this up. So this is the square root of 5 times 5 is 25. So this is 25x squared. 5 times a negative 1 is a negative 5. This cleans into or simplifies into 25x squared, and the square root of 25x squared is just 5x. So you can see that they're different values. Sometimes, every now and then they'll be the same, but most times they're not. Okay, so let's go down to example 5. Now this one's different. This one is different because now they're not giving me x, they're giving me a number. So when they give me a number, just as with the operations of sum, difference, multiplication, and quotient, the answer is going to be a number. Okay, so this is f of g of 9. Instead of f of g of x, it's f of g of 9. And g of 9 is going to be a value, a number. So let's come out here and figure out what in the world does g of 9 equal. Well, g of 9 is just 2 times 9 minus 8, which is 10. Okay, so now I come back, and this is now f of 10. Okay, so now I bring the value in. It's just 10. So now I go to the f function, and in place of x I put 10. So this is 3 over 10 minus 4, which is 3 over 6, which is just 1/2. I'm at the really very bottom of my page, and I cannot scroll that up. But that's 1/2 down there. Okay, so now g of f of 6 is g of f of 6. Remember, they give you a number, your answer is going to be a number. Come over here and figure out what in the world is f of 6. Okay, f of 6 is go to the f function and replace the x value as 6. So this is 3 over 6 minus 4, which is just 3/2. So this is g of 3/2. Okay, go to the g function, which is 2x minus 8, and put 3/2 in it. So this is 2 times 3/2 minus 8. The 2's will cancel out or divide out as a 1. So this is just 3 minus 8. This is a negative 5. So the numbers are actually, I think, maybe a little easier. Maybe a little bit easier when you're doing the numbers. So if you start with a number, your answer is going to be a number. Okay, now is where it can get a little bit tricky. So now what we're looking at again. We did the sum, difference, product, quotient. Then we did the domain of the sum, difference, product, quotient. Then we did composition. And now we're doing domain of composition. All right, so here we go. Find the domain of f composition g of x. All right, so to find the domain of f composition g of x, let's first write what in the world is f composition g of x. Well, it is f of g of x. Okay, f composition g of x is f of g of x. Okay, so let's take a look at the domain of g of x. Well, g of x has no fraction and no radical, So this is no problem. This is all real numbers. This is no issue. We got it covered. So then let's look at what this turns out to be. F of g of x is f of 4x minus 2. So that means go to where the f function is and replace that x with that stuff in the square brackets. So this would be the square root of 4x minus 2. Okay, now we got to talk about this. When we talk about the domain here, we know that 4x minus 2 must be greater than or equal to 0. It must be positive. And if I solve this by adding 2 to each side, I'm going to get x greater than or equal to 1/2. So to find the domain of the composition, I collectively look at both of these and put them together. One is all real, so if I looked at the number line, one of them is everything, no restrictions, and the other says I have to be greater than or equal to 1/2. So the part that they have in common is the domain of the composition. So the domain of the composition is going to be from 1/2 to infinity. Okay, and then when they reverse the composition, the domain is going to change also in part B. Ooh, I don't want to lose my functions though. Okay, so this one is g of f of x. So if I'm going to start with f of x, I've got to know what the domain of f of x is. Well, we just kind of looked at it. Okay, domain of f of x. If it's the square, if f of x is the square root of x, then the domain of f of x is what? X must be a positive number. X must be greater than or equal to 0. So that's my first restriction. I've already started out with only half of my numbers, right? Half of all my numbers. So now I take a look at this. This is g of the square root of x, because that is what f of x is. And so this becomes 4 times the square root of x minus 2. So the restrictions on this is I just have a square root. I don't have a fraction or anything. So this remains x greater than or equal to 0. Because the only thing I have is a square root of x again. So when I look at both of these combined, what is it going to be? Greater than or equal to 0, right? So 0 to infinity. So you can see the domain is different. Yeah, I can scroll it up. There you go. You really have to play with these, and you have to go step by step. You don't look at it all in one image. You go step by step and let it progressively take you to the answer. Okay, so you know this one's going to be fun. You got 2 big fractions here. 2 big fractions. Okay, and we know from the get-go, well, we'll just jump in here. Okay, so this is f of g of x, the first one. So looking at g of x, what is the domain of g of x? What can I not have? X cannot be what?
0.
There we go. Knock that one out. Okay, so this becomes f of 1 over x, which is, oh my, right? Oh boy. This is going to be, wow, let me pull the highlighter up here. Everywhere there is x, everywhere there's an x, I'm going to replace it with 1 over x. Right? Okay, so here we go. So this becomes 1 over x minus 1 over 1 over x minus 3. Okay, so right off the bat with these fractions, we know x cannot be 0. We've already got that covered, period, because that makes those little fractions undefined. But in the big fraction, this is a denominator itself, right? So in addition to that, we know that 1 over x minus 3 cannot equal 0 either, because it's the denominator of the big ugly complex fraction. So I have to solve this. So this is 1 over x cannot be 3 when you add the 3 to the other side, which means that x cannot be 1/3. So when we put all of this together, we have two exclusions. X cannot be 0, and x cannot be 1/3. So to write that in interval notation, it's negative infinity to 0, 0 to 1/3, and 1/3 to infinity. I'm going to try to move this over a little bit. I'd like to put it all in one string. I don't like to have to bust it up. Okay, so it's going to be negative infinity to 0, 0 to 1/3, and then 1/3 to infinity. That's how you eliminate those two numbers. All right, one more. G composition f of x. Hope I can fit it down here. So this is, I'm going to try to move this one up because I don't have enough space. Okay, so this is G of f of x, and then we have to figure out what was our limitation on f of x. Okay, what value can I not have in f of x? The domain, whoops, might just hit the eraser. Okay, the domain of f of x is that x cannot be what? Look up here. In the denominator, what would make that denominator equal 0? 3. X cannot be 3. There's one exclusion already from our answer. Okay, so this becomes g of x minus 1 over x minus 3. Okay, so go to the g function. I'm going to hit it with the orange highlighter. Well, it's a deep orange color. Okay, so this becomes, oh my, right? 1 over all this mess in the denominator. This is what we call a complex fraction. Big ugly fraction. We've already said that x cannot be 3, which is correct. But now this is the bottom of a big ugly complex fraction. So now we have to say x minus 1 over x minus 3 cannot be 0. And if we cross multiply this, then this becomes x minus 1 times 1 equaling 0. Or x cannot be 1. Okay, so the answer to this one is we have two exclusions. X cannot be 3 and x cannot be 1. So this becomes negative infinity to 1 in union with 1 to 3 in union with 3 to infinity. Up higher, like that. So our last page is going to be pretty easy. Finally, we break into something a little easier, okay? Thank goodness, right? Thank goodness. Grief. Okay, so this is almost like a little bit of a summary. This is a chance for you to breathe again, kind of come out of that deep thought, because those are kind of hard. And this first one would be f of 3 minus g of 3. And we're going to go to the graph and look at this. So remember, your x's are 3's, and our f is the blue line, and our g is the red line. So if I go to an x value of 3 and go up to the blue line, it's at a height of 4, right? So this would be 4. And what is g of 3 on the red line? 3. So 4 minus 3, this answer, thank goodness, is something a little bit easier than all that domain of composition. Okay, so this one, part 2, is g of negative 2 over f of negative 2. So here your x value is negative 2. Your g, remember, is your red line. So what is g of negative 2? Negative 4. And f of negative 2 on the blue line is a positive 2. Isn't this a lot better than the last page? Okay. All right, here's a composition. So this is g of f of 1. So first I have to find f of 1. Okay, f of 1 is my blue line. When the x value is 1, the blue line has a y value of 2. And now g of 2 is go to the red line where the x value is 2, you get a y value of 4. You aren't so quiet, thank goodness. Okay. So these we'll do we're about to run out of time here. So this is going to be f of g of negative 3. G of negative 3 is the red line. When x is negative 3, 1, 2, 3, y is 1, 2, 3, negative 4. So this is f of negative 4. And what is f of negative 4? At the end of the arrow, huh? 1, 2, 3, 4, 1, 2, negative 2. And one more. F, I know there's a word problem down there, but it's okay. This is an interesting one here, number 5. Okay, one step at a time. You're always on the blue line. F is the blue line. Okay, f of negative 3, 1, 2, 3 is right here. Is a y value of what? 0. And then f of 0, back to your blue line. When x is 0, what is y? 2. There you go. Okay. So I think that we finally can say we've ended this section. There's a word problem down there. We're not going to be too concerned about it, but we'll stop it here.